In the present video, I will discuss the how to solve a maximization case in a transportation problem. Objective of this case is to maximize the total profit for which the profit matrix is given. For this, first you have to convert the maximization problem into minimization by subtracting all the elements from the highest element in the given transportation table. After that, this modified minimization problem can be solved in the regular manner. Let's see the example problem. Solve the transportation problem to maximize the profit. Here it is given the three sources S1, S2, S3 and four destinations D1, D2, D3 and D4. Let's see the solution. First we have to cross check the whether given transportation problem is balanced or not. Here total demand equal to the 23 plus 31 plus 16 plus 30 which is equal to the 100, and total supply equal to 23 plus 44 plus 33 which is equal to 100. So total demand equal to the total supply. Then given transportation problem is balanced. Given problem is the maximization model. So first we have to convert the maximization model into minimization by subtracting all the elements from the highest element in the given transportation table. Here highest element is the 90. So subtract all the elements from 90. The table will be modified. So first element 15. So 90 minus 15, this is the 75. 90 minus 51, 31. 90 minus 42, 48. 90 minus 33, 57. And 90 minus 80, 10. 90 minus 42, 48. 90 minus 26, 64. 90 minus 81, 9. And 90 minus 90 equal to the 0. And 90 minus 40 equal to the 50. And 90 minus 66 equal to the 24. And 90 minus 60, that is the 30. So next step is find the initial basic feasible solution of a given transportation problem by using the any of the three methods. Here we are applying the VAM method to find the initial basic feasible solution. First we determine the penalty for each row and column. Here penalty is the second minimum value minus minimum value. So first to calculate the penalty for the rows. In the first row minimum value is the 39 and the next minimum value is the 48. So penalty is the 48 minus 39 which is equal to the 9. So in the second row minimum value is the 9 and the next minimum value is the 10. So penalty equal to the 10 minus 9 which is equal to the 1. In the third row minimum value is the 0. Next minimum value is the 24. So 24 minus 0, the penalty equal to the 24. Similarly, we have to calculate the penalty for the each column. So in the first column, D1 column, minimum value is the 0 and next minimum value is the 10. So penalty is the 10 minus 0 equal to the 10. In the second column, D2 column, minimum value is the 39 and next minimum value is the 48. So penalty is the 48 minus 39 which is equal to the 9. In D3 column minimum value is the 24 and next minimum value is the 48. Then penalty equal to the 48 minus 24, that is 24. Similarly in the D4 column minimum value is the 9 and next minimum value is the 30. So penalty is the 21. Next to choose the maximum penalty. Here maximum penalty is the 24 for the S3 row and also for the D3 column. So it is the time for the penalty. In this condition, we have to select the row or column which having the minimum cost. First we have to look for the S3 row. In the S3 row, minimum value is the 0, and in D3 column, minimum value is 24. Among the 0 and 24, minimum cost is the 0 and it is for the S3 row. So we have to select the 0 for the S3 row. So at the 0 cost cell, observe the supply and demand and allocate the minimum value of them. Here supply is the 33 and demand is the 23. So minimum value is the 23. So allocate the 23 at 0 value cell and subtract the 23 in the demand as well as the supply. Then demand will become the 23 minus 23 equal to the 0 and supply will become the 33 minus 23 which is equal to the 10. So here D1 column getting the 0, then remove the D1 column. So next we have to determine the penalty for the each row as well as the each column. So first we have to calculate the penalty for the rows. For the S1 row, minimum value is the 39 and next to minimum value is the 48. So penalty is the 9. In the S2 row, minimum value is the 9. Next to minimum value is the 48. So penalty is the 39. In the S3 row, minimum value is the 24. Next to minimum value is the 30. So penalty is the 6. Similarly, we have to calculate the penalty for the columns. So first column, there is no D1 column. So for the D2 column, minimum value is the 39 and next to minimum value is the 48. So penalty is the 9. And for the D3 column, minimum value is the 24. Next to minimum value is the 48. Penalty is the 24. And D4 column, minimum value is the 9 and next to minimum value is the 30. So penalty is the 21. So among all the penalty values, maximum penalty is the 39 for the S2 row. Then you have to select the minimum value in the S2 row. So minimum value in the S2 row is the 9. So here you have to observe the supply as well as the demand. So here supply is the 44 and demand is the 30. Then allocate the minimum value. So here minimum value is the 30. So allocate the 30. Then subtract the 30 in the supply as well as the demand. Then demand will become the 30 minus 30 0 and supply will become the 44 minus 30 it is the 14. Here D4 column is getting the 0, then remove the D4 column. Next to calculate the penalty for the rows as well as the columns. For the first row penalty is the 9 and the second row penalty is the 16 and third row penalty is the 26. Similarly for the column, here there is no D1 column. For the D2 column, penalty is the minimum value 39 and next to minimum is the 48, it is the 9. And for the D3 column, so minimum value is the 24 and next to minimum value is the 24 and there is no D4 column. Then among these values, we have to choose the maximum penalty. Here maximum penalty is the 26 for the S3 row. Then you have to solve the S3 row. In the S3 row, minimum value is the 24. Then observe the at 24 supply as well as the demand. So here supply is the 10 and demand is the 16. So minimum is the 10. So allocate the minimum value, that is the 10. Then supply will become the 10 minus 10, it is equal to the 0. And demand will become the 16 minus 10, it is equal to the 6. Here, so here S3 row getting the 0, then we have to remove the S3 row. Next we have to determine the penalty for the rows as well as the columns. For the S1 row, penalty is the 9 and S2 row penalty is the 16 and here there is no S3 row. Similarly, have to calculate the penalty for the columns. There is no D1 column. For the D2 column it is the 9 and the D3 column it is the 16 and there is no D4 column. So among all the penalties we have to choose the maximum penalty. Here maximum penalty is the 16 for the S2 row as well as D3 column. So here once again type for the penalties. So now we have to choose the minimum value. For S2 row, minimum value is the 48 and D3 column, minimum value is the 48. So here minimum cost also type, then observe the maximum allocation. For the D3 column and S1 row cell, here you have to observe in these two cells you have to observe the allocation values. First we have to check the allocation for the S1 row as well as the D3 column. So here observe the supply as well as the demand. So minimum is the demand, that is the 6. Then allocate the 6. Similarly observe the S2 row as well as the D2 column. So here observe the supply is the 14 and demand is the 31. So minimum is the 14. So here we are getting the allocations are the 6 and 14. In this condition we have to choose the maximum allocation. So maximum allocation for the S2 row and the D2 column cell. So then we have to solve this cell. So here observe the supply as well as the demand. So supply is the 14 and demand is 31. So allocate the minimum value, that is the 14. Then have to subtract the 14 in the supply as well as the demand. Supply will become the 0 and demand will become the 17. So here S2 row getting the 0, then have to remove the S2 row. So next to determine the penalty for the rows as well as the columns. So here for the S1 row penalty is the 9 and here there is no S2 row and S3 row. Similarly have to calculate the penalty for the columns. For D1 column, so we are not considering, there is no D1 column. For the D2 column 39 and D3 column 48 and here there is no D4 column. So among these penalties I have to choose the maximum value. Here maximum is the 48. Then at the 48 we have to observe the supply as well as the demand. So supply is the 23 and demand is the 6. So minimum value is the 6. We have to allocate the 6. Then subtract the 6 from the demand as well as the supply. So supply will become the 17 and demand is the 0. Here D3 column getting the 0. Then have to remove the D3 column. So next to last one 39. Here observe the supply as well as the demand. So both are the 17. Allocate the 17 and subtract the 17 from the supply as well as the demand. Both will get the 0 and remove the row as well as the column. This is the initial basic feasible solution. Next we have to find the set numbers Ui and Vj for the each row and column which satisfying the Ui plus Vj equal to the Cij for each occupied cell. So Ui values for the rows and Vj values for the columns. So here we are having the 3 rows. So we will get the 3 U values, that is U1, U2 and U3. Similarly here we are having the 4 columns. So we will get the 4 V values, that is V1, V2, V3 and V4. Next assign a number 0 to any row or column which having the maximum number of allocations. If this maximum number of allocations is more than 1, choose any one randomly. So first we have to determine the number of allocations row wise as well as column wise. So in the first row number of allocations are the 2. In the second row number of allocations are the 2. In the third row, number of allocations are 2. Similarly, in the column wise, first column number of allocation is 1. In second column number of allocations 2. In third column 2. In fourth column 1. Here maximum number of allocations are the 2 for the S1, S2, S3 rows and also for the D2, D3 columns. So among these, randomly we have to allocate the set number as the 0. So here we are allocating the set number as the 0 for the U3. So then we have to solve the row S3 which having the 2 allocations. So one allocation is at the S3 and D1 column. Another allocation is at the S3 row and D3 column. So first we have to solve these 2 cells. We will get the another set numbers. First we solve the S3 row and D1 column cell. So its cost value is the 0. So C31 equal to the 0 and we know the relation C31 equal to the U3 plus V1. We know the C31 value and also U3 value. Then substitute, then we will get the V1 equal to the 0. So next we have to look for the another allocated cell, that is S3 row and D3 column. Here its cost value is the 24. So that is the C33 equal to the 24 and we know relation. So C33 equal to U3 plus V3, then substitute U3 value as well as C33 value, we will get the V3 value, that is the 24. So next we have to go for the, we know the V1 value as well as V3 value. So in the V1 column we are having the only one allocated cell, that is already we solved it. So in the V3 column here having the 2 allocations. So first cell already we solved. Next we have to look for the another cell, one another occupied cell, that is the S1 row and D3 column. So here C13 value. So C13 equal to the 48. We know the relation C13 equal to the U1 plus V3. Then we have to substitute. So C13 value as well as V3 value. Then we will get the U1 equal to the 24. So next we know the U1 value. Then I have to solve the another allocated cell, that is the S1 row and D2 column. Its cost value is 39, which means C12 equal to the 39 and we know the relation C12 equal to U1 plus V2. So here we know the C12 value as well as the U1 value. Then we will get the V2 value. So V2 value is the 15. So next we know the V2 value. Then we have to solve the another allocated cell at the S2 row and D2 column. That is here C22 value is the 48 and we know the relation C22 equal to U2 plus V2. Here we know the V2 value as well as C22 value. Then we will get the U2 value, that is the 33. So next we have to solve for the last one. So here we have to solve the V4 value. So for this V4 we have to select the allocated cell, that is the S2 row and D4 column. Its cost value is the C24. C24 equal to U2 plus V4. So here I have to substitute C24 value is the 9 and U2 value is the 33. Then we will get the V4 is the minus 24. Next step is find the net evolution value for each empty cell. That net evolution value is the delta ij equal to Cij minus of Ui plus Vj. So here empty cells are in the S1 row and D1 column. So here delta value is the delta 11. Similarly, another empty cell, delta 14, another empty cell, delta 21, another empty cell at the delta 23. Next empty cell is 32. So here we have to find the delta 32 value. Similarly, delta 34 value. So we know the relations, delta ij equal to Cij minus of ui plus vj. So which means delta 11 equal to the C11 minus of u1 plus v1. So here we know the C11 value as well as u1 and v1 value. C11 value is the 75 and u1 value is the 24 and v1 value is the 0. Then substitute, here we will get the 51. So next one is the delta 14. So delta 14 is the C14 minus of u1 plus v4. C14 value is the 57. Then v1 value is the 24 and v4 value is the minus 24. Then substitute, here we will get the delta 14 value is the 57. So next we have to determine the delta 21. So delta 21 equal to the C21 minus of u2 plus v1. So here we know the C21 value is the 10 and u2 value is the 33 and v1 value is the 0. Then substitute here, delta value we will get the minus 23. Next delta 23. So for the delta 23, which is equal to the C23 minus of u2 plus v3. Here C23 value is the 64 and u2 value is the 33 and v4 value is the 24. Then substitute, we will get the delta value is 7. Next delta 32. So delta 32 equal to C32 minus of u3 plus v2. C32 value is the 50 and u3 value is the 0 and v3 value is the 15. Then delta 32 value is the 35. Next delta 34, which is equal to the C34 minus of u3 plus v4. C34 value is the 30 and u3 value is 0 and similarly v4 value is the minus 24. Then we will get the delta 34 equal to the 54. So next step is, so observe the delta ij values and observe the another three conditions. First one is, if all the delta ij values are the greater than 0, then solution is optimum and a unique solution exists. If all the delta ij values are greater than or equal to 0, then solution is optimum but alternative solution exists. If at least one delta ij is less than 0, then solution is not optimum and go to the next step. So here delta 21 value, it is the minus 23, which is less than 0. Then we are not getting the solution is not optimum. So then once again we have to go for the next step. Here delta 21 is the negative value. So for the cell S2 row and D1 column, consider cell allocation value is the plus x. Next we draw a closed path from this cell and assign the plus x and minus x allocations alternatively. So this is the closed path. Next we have to allocate the plus x and minus x allocations alternatively. So first one we are allocated the plus x. So next one is the minus x. So it is already having the initial allocation 23. Then here allocation value is the 23 minus x. Next one 10 plus x. Next one 6 minus x. Next one 17 plus x. Next one is the 14 minus x. So next we have to find out the x value. For this we have to check the minus x positions and minimize it. Here minus x positions are the 23 minus x, 6 minus x and 14 minus x. Among this minimum value 6 minus x, then minimize it, 6 minus x equal to 0, then x value is the 6. Then substitute x value equal to this 6. Then allocations will be modified. So here, so at the cell S2 row and D1 column, here initially we are allocated the plus x. So here x value is the 6, then its allocation value is the 6. And here 23 minus 6. So it will become the 23 minus 6, that is the 17. And here 10 plus x. So here 10 plus 6, that is the 16. Here 6 minus x, 6 minus 6, 0. So we have to remove the here allocation. Next to 17 plus x, that is 17 plus 6, 23. So next one is the 14 minus 6, that is 14 minus 6, that is the 8. Next we have to find the set numbers ui and vj for each row and column, which satisfying the ui plus vj equal to the cij for each occupied cell. Before that, we have to determine the number of allocations row wise as well as the column wise. In the first row, number of allocations is the 1. In the second row, number of allocations is the 3. Third row, 2. And first column, number of allocations are the 2. In the second column is 2. In third column 1. In fourth column 1. So among these allocations, maximum number of allocations for the S2 row. So U2 value is considering the 0. So next we have to solve this U2, that is in the S2 row. Allocations are S2 row and the D1 column, and S2 row and D2 column, and S2 row and D4 column. So first we have to solve this one by using the Cij equal to Ui plus Vj. First we have to solve the C21. So C21 equal to the U2 plus V1. We know the U2 value. Then we will get the V1 equal to the 10. Next to here C22. C22 equal to the U2 plus V2. Then we know U2 equal to the 0 and C22 is the 48. Then V2 value is the 48. Next one is the C24. So C24 equal to U2 plus V4. Then V4 equal to the 9. So here we know the V1 value. So in the V1, so D1 column we are having the another allocation, that is its cost value is the C31. So C31 equal to 0. Then we know the C31 value as well as V1 value. Then substitute here, we will get the U3 value is the minus 10. So next we know the V2 value. So in the V2, so second column we are having the another allocation, that is so in the S1 row and D2 column. So it's C12 value. C12 value is the 39. C12 equal to U1 plus V2. We know the V2 value as well as C12 value. Then U1 value will become the minus 9. So next to here we know the U3 value. Then another one more allocation is there in the third row, that is the C33. So C33 equal to U3 plus V3. So here we know the U3 value as well as C33 value. Then we will get the V3 equal to 34. Next we have to find the net evaluation value for the each empty cell, that is delta ij equal to Cij minus of Ui plus Vj. So here empty values are the delta 11, delta 13, delta 14, delta 23, delta 32 and delta 34. So first one, delta 11, we know the relation delta ij equal to Cij minus of Ui plus Vj. Then delta 11 will become the C11 minus of U1 plus V1. Here delta 11 value is the 74. Similarly delta 13 equal to the C13 minus of U1 plus V3. So substitute all the values, then delta 13 will become the 23. Next to delta 14 we will get the 57. Next to delta 23 30 and delta 32 equal to 12. Next to delta 34 is 34. So here observe all the delta ij values are the positive, which is greater than 0. Then solution is optimum and unique. Then we have to write down the initial transportation table. So this is we got the final optimal solution. So this is the initial transportation table. So next we have to write the same allocations here. So these are the allocations. Then given problem is the maximize. So we have to determine the maximum profit. Then maximum profit will become 51 into 23 plus 80 into 6 plus 42 into 8 plus 81 into 30 plus 90 into 17, 16 into 16. Sorry, 66 into 16. Total cost is the 7,005. So this is the solution, and thank you.